prove it's a parallelogram, we've got our normal, like, properties that we went over yesterday. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. This one is this top one is the first one that's a little bit different. We didn't bring it up yesterday. But to prove that you have a parallelogram, one of our options, if you have one pair of opposite sides that you can say are congruent and parallel, so the marking that we have here, it proves to be a parallelogram. So that's just a little bit of an extra one. And then same as yesterday, our diagonals, if they bisect each other. So what we're looking at today, there's different ways to prove that something is a parallelogram. We got 6 different ways. So when it comes to both pairs of opposite sides are parallel, if it was something like on a coordinate plane, you would have both their slopes. Matching slopes, opposite sides are congruent, so that would be like the distance formula. Consecutive or diagonals bisect each other. What would you use on a coordinate grid to prove that diagonals are bisecting each other? Midpoint. Using the midpoint. But what you would have to do if it's not proven that it is a parallelogram, you would have to find the midpoint of both diagonals. And as long as it's the same point, that proves it. And then opposite sides are congruent. That would be a combination of your distance formula and slope. So those are all just on the, like if it was a coordinates that I was giving to you. So we're going to go through and prove some things are parallelograms. We're also going to go through some like harder parallelogram questions. And what I mean by harder is throwing in like quadratics, throwing in systems, things like that. Because yesterday was more of just like really basic. Can I go to the next page? So on this first parallelogram, this is the marking. Which of our reasonings is the justification to make it a parallelogram? Huh? C. Correct. Something just to notice, I mentioned it yesterday, but just to mention it again, the arrows are representing parallel. Arrows do not represent congruent. So you either need to have the number 15 or you have to have tick marks to represent congruency. Just make sure you're careful with that part when we're looking at pictures, because sometimes based off of a picture, you have to be able to tell that it is a parallelogram based off of markings. Okay, so on these two, the next set of problems. Finding the value of x and y in our diagram. Here's our setup. It says it's a parallelogram, so we know that opposite sides are congruent. And we know that the opposite angles are congruent. Which then means solve them. The easier one to solve is that quadratic, or the one that x squared curves. And x equals -7, right? Now, where it's going to matter, we're going to cross out one of those answers if when we plug in and solve for y, it makes something that wouldn't be justified. So this is talking about like angles and sides. So our angles have to be less than 180, but more than 100. So just things like that. So when we plug our +7 in, so y is 8. And then option 2. So that's part, just to be careful, because we have two x values and two y values. So that's just something I always remember when it comes to quadratics. Possibly two answers. Do both answers work when you plug them back in? Okay. Then for this second one. For the second one on that paper, what's true about these two things? They're supplementary, which means plus, what is that? Right? Did I have that correctly? Yes? Okay. So what's x? 10. Which then means since that's 10, what's our y value? 13. We okay with those? All right. On the next set. Okay. Next set, we're determining if the quadrilateral is a parallelogram. To figure out if a quadrilateral is a parallelogram, this one says justify using the slope formula. If I tell you the specific formula to use, then I'm asking, like, there's a certain way I want you to justify it. If it just says, is it a parallelogram, nothing like telling you what to use, then it doesn't matter. Since I'm saying use the slope formula, what are we trying to prove within that figure? That we have parallel lines, that the opposite sides are parallel. So QR should be parallel with ST, and then QT should be parallel with RS. So find the slope of each of those. QR is -1/2, -1/2, 4 and 4. So proved opposite sides are parallel. We okay? I want y'all to do the next one. It doesn't say how to prove it, but I want y'all to do this next. All right, is this the right order? Yes, okay. Oh, that's weird. Okay. I have the points up here. I don't know how that. Okay, so just prove that it's a parallelogram. Whatever method you want. So whether you want, like, we went through the different ones, pick the different one you want. So on the next one, it's labeled with diagonals. What's true about the diagonals of a parallelogram? They bisect each other. So those two are congruent. And then these are congruent. So we're solving for x and y. Go ahead and do that. I want to have us go through this one together because I want to make sure that we're all good for factoring. What's true about those two angles? They're supplementary. So x squared plus 2x plus 145 equals 180.
Wait, where do you get the
7x and then.
I combine these two. So then x squared plus 2x minus 35 equals 0. This is an easy factoring. What I mean by that, the number with x squared is 1, like coefficient. So all we're looking for, the numbers that multiply to give you negative 130 or negative 35, but add up to 2. Which would be a positive 7 and a negative 5. So for the two numbers, negative 7 and 5. Using those numbers, when you go back to plug them in, do both numbers plug in and create possible angle measurements? So if you plug in negative 7, that would be what? 49 plus 35. So 84 degrees, which would make this 96 degrees. So that's good. Totally fine. If we plug in 5, that would be 5 squared, so 25 minus 25, which is 0. That is never going to be an option, so that is not a nice value. Which is a little bit backwards. I think sometimes we get in the habit of like, oh, the negative 1 just isn't going to be an answer. So it's just something to like be aware of. You do always have to check it. Okay. I want y'all to do both of these next month. I want y'all to try a little bit, or try it without me. When it says justify your setup, how come you're able to set up what you're doing right now for that first one? What's your setup that you're going to be doing? What's true about these two? They're supplementary? Right. So that's why you have these two. So you can just say that one out loud instead of writing it out. Then we need to see it more full out. How's the second one going? Can anyone get 1 point that we have to have? 0, 2. Right? How did you get that, Henry? Okay, yeah. So find the slope of QR. So if you do the slope off of the other point, it would have to be there. So 0, 2. That's one of them. And let me actually, oops. You know where another one could be located? -2, -4. Yep. Right there. Because then it makes this parallelogram. And there's one more. If you find the slope between these two, then go off of this one and go up to the right. So at 10, 6. Generally, when you see these questions, when it's talking about a parallelogram and then what's the possible third point, most times it's 3 answers. Generally. Sometimes it's just depending on the, we'll do this again with different figures, but generally, it's 3 points. Okay, that was our last one for class. There are others on your notes, but we've done them. I don't need all this.